Section 4.3, modeling with quadratic functions. We're going to model data with quadratic functions. Most of the time these are word problems that you have to figure out what the parabola equation is. And we're going to do just part of it today on paper. Hopefully we'll do the calculator part tomorrow. I'll show you just a little bit of each. Problem number 1. A parabola contains the points 0, 0, -1, -2, and 1, 6. What's the equation of the parabola in standard form? Remember, standard form looks like this. So y equals ax squared plus bx plus c. What we're going to do is find the equation that hits every single one of these points exactly. So we're going to substitute the x, y values for each one of these into 3 different equations, and then we're going to solve using elimination or substitution, and finally substitute back in to find out what the final equation is. So for the ordered pair 0, 0, the equation looks like this. 0 equals, so 0 for the y, a times 0 squared plus b times 0 plus c. Now the zeros, when you're multiplying, cancel out, so you get 0 equals c. Now the good part about this one is that we've already found out what c is, so I'm going to go back and say, now my equation looks like this. Okay, or you can just leave that off. So my second ordered pair is -1, 2. Okay, what's going on? -2, I better put in there. So -2 in for the y, and -1 goes in for the x. So a times -1 squared plus b times -1. Remember, c was 0, so we're leaving that off. -2 equals 1a minus b. That's one of our equations that we need. The other one is found using the 1, 6. 6 goes in for y, 1 goes in for x. Simplify it and you get 6 equals a plus b. Now we're going to put these two equations together. So a minus b equals -2 and a plus b equals 6. They're already set up in elimination form, so 2a equals 4, a equals 2. Then we plug it back in to find out what b is. 2 plus b equals 6, b equals 4. And then we plug it back in, so into the very, very beginning, and get our equation. So my equation looks like this. Y equals 2x squared plus 4x plus 0. You can either leave the 0 in or take the 0 out. Second one looks very similar. We have a 0, 0 again, which will give us c equals 0, and then we have 2 other ordered pairs. I'm going to do the 0, 0 again, just so you don't forget what we did. Remember, my equation is y equals ax squared plus bx plus c. That's what we're plugging into. 0 in for y. A 0 in for the x's makes c equals 0. The 1, -2 becomes -2 equals a times 1 squared plus b times 1 plus 0. The c is 0 again, so I plugged that in already. -2 equals a plus b. That is one of my equations. -1, -4 gives me the other one. So -4 equals a times -1 squared plus b times -1 plus 0 again, because c was 0 at the beginning. I'm going to put a star by that one because that's part of our answer. Simplifying this one, we get -4 equals A minus B. We're going to put those two together. A plus B equals -2, and A minus B equals -4. It's already set up to do elimination, so 2A equals -6, A equals -3. Plug it back in to find B. -3 plus B equals -2, B equals 1, and then rewrite it to get the final answer. Y equals -3x squared. I plugged in a -3 for A, plus B, or B is 1, so 1x plus 0. Again, you can leave the 0 off since the 0 doesn't really change the answer. Here's the story problem about launching rockets. Campers at an aerospace camp launch rockets on the last day of camp. The path of the rocket number 1 is modeled by the equation h equals -16t squared plus 150t plus 1. T is the time in seconds, that goes on the x-axis. H is the distance from the ground, that goes on the y-axis. The path of rocket 2 is modeled by a graph on page 210. Which rocket flew higher? So with rocket number 1, we looked at yesterday the height of that bridge, and we did that by finding the vertex. So that's what we're going to do first today. So remember, the vertex is found by first finding -b over 2a and then plugging it into the equation. So in our equation, A is -16, B is 150, and C is 1. So we're just going to plug those things in. I'm going to do it off to the side. So -150 divided by 2 times -16, and we get about 4.7. So the first part of the vertex is 4.7. What we're going to do is plug it in. So -16 times 4.7 squared plus 150 times 4.7 plus 1. And you get 352.56. So we'll call it 352.6. Okay, so the height of the rocket, this is the time, 4.7, and the height would be the 352.6. So height equals 352.6 feet. Okay, for rocket 2, we're going to look in the book, and we have a picture that kind of looks like this. It starts at 0, 0, goes to 12, 0, and then what they're going to do is they're going to estimate how much this is. Now, really, they should be using equations like we did in those first two examples, and if they are, we can pick any points that we want that we know exactly what they are. They estimate this about 580 feet. You estimate might be 585, 590, 575. It doesn't really matter as far as the estimate goes. So rocket 2, the height equals 580 feet. So which rocket was higher? Rocket 2. If you were planning on doing this exactly, so if you were using 3 equations, what you would do is you look for 3 ordered pairs taken out of the graph. and then solve using elimination or substitution. And you would get something very similar, but it would be a more exact ordered pair. Now we're going to answer some questions about the rockets. Which rocket stayed in the air longer? That has to do with time, and time has to do with the x-axis. So when you look at the x-axis for both of these, rocket 2 is 12 seconds, because from start to finish it was 12 seconds. Rocket 1, if we go up a little bit again, rocket 1 was 4.7 seconds halfway across. So for rocket 1, you'd have to take 4.7 times 2, which would be 9.4 seconds. Because remember, the vertice, or the vertex is only halfway across, so you'd have to double it to get all the way across. So rocket 2 stayed in the air longer and went the highest. What's a reasonable domain and range for each quadratic model? I'm going to show you two different ways. So rocket 1, the domain looks like this. If we look at the x-axis, the domain went from 0 to 9.4. The book will say 0 less than or equal to t less than or equal to 9.4 because the x-axis stands for time. The range value goes from 0 to 352.6. I think that was right. Yep. And then in the book, they'll go 0 less than or equal to height less than or equal to 352.6. Okay, so you can do either or. Rocket 2. The domain would be 0 to 12. The squared off brackets mean the points are included. So 0 less than or equal to t less than or equal to 12. And the range is 0 to 850. Or 0 less than or equal to height less than or equal to 850. Domains and ranges for both. Describe what the domains tell you about each of the models and why the domains of the models are different. We'll think about rockets in that every time you shoot a rocket, it's probably going to go a different distance due to many factors. So the domains tell you the amount of time the rocket is in the air. Different models would be in the air at different amounts of times. Tomorrow, we're going to go through problem 3, and it's going to be on the graphing calculators. We'll have to just see how we do. We may or may not get the whole thing done to have an assignment, so we'll just have to wait and see.